So number 24 on page, what is this, 212?
221.
Okay, 221. Our end goal is to find the area of a regular octagon. So we know that that formula is area equals 1/2 times apothem times capital P stands for the perimeter of this regular polygon. The fact that they tell us it's an octagon, it's extremely important because that gives us n, the number of sides. And if it's an octagon, the number of sides is?
8.
8. Okay? But we need something else. We need one more piece of information, and that will be one of three things. They're either going to give you the length of the apothem, and that would be awesome because then you can just plug that in, and all you got to do is figure out the perimeter. They could give you the length of the radius. Remember, for a regular polygon, the radius is from the center of that regular polygon to a vertex. That's that distant. And then, or the third thing they could give you is a side length. And if they give you a side length, then you can quickly figure out what the perimeter is. Just take that side length and multiply it by the number of sides. And then you still have to find out what your apothem's length is. But so those are the three things. So you cannot solve for the area of a regular octagon unless you have either the radius, apothem, or side length. So the second thing that this problem says is that the regular octagon is inscribed in a circle whose equation is the quantity x minus 2 squared plus quantity y plus 3 squared. And that equals to 25. So this is kind of a blast from the past. And we did problems like this on workbook page 202 and 203 when we dealt with the equation of the circle. Can someone remind me in the class what the general form of the equation of a circle? You got it, Alice?
X minus x1, what is it, x1?
It is the coordinates of, right. Does anyone remember the variable that we use for the x coordinate?
Oh, h.
Yeah. Okay, good. So we got h
Squared plus y minus k
yeah.
squared equals radius squared.
Good, radius squared. And then when we learned that, we just said that's an application of Pythagorean's theorem. You've got a squared plus b squared equals c squared. So it's just an application of that. So, and when we first learned about these regular polygons, over here, I drew us a circle, and I said, what if we had I said that these regular polygons, I happen to draw a hexagon, but I said that these regular polygons, every single one of them can be inscribed in a circle. And to be inscribed, that means all of the vertices of the polygon will be on the circle. Just like in an inscribed angle, its vertex is on the circle. And so we started talking about those special segments. And we said that one of them was an apothem. It goes from center straight down to one side length. And it's perpendicular to that side length. Then we said one of them is the radius. So whenever, I know that I drew a hexagon, but whether you have a triangle, quadrilateral, hexagon, octagon, dodecagon, whatever, it will be able to be inscribed in a circle. And so the radius of that circle is the same as that as the radius of that regular polygon that is inscribed in that circle. So by them giving you the equation of the circle that it's inscribed in, you can determine what the radius is of that circle. And so the radius of this regular octagon will be the exact same as the radius of the circle. Thumbs up, medium, or down about that. Radius of the circle is the radius of the regular polygon. Okay. So what is the radius of this circle, of the equation given here?
Square root of 25.
And so what is the square root of 25?
5.
It is 5. So since radius is a length, we can disregard the negative value. Because remember that if we have r squared is equal to 25, then technically r is positive and negative 5. But since radius, that's describing a length of a segment. It's talking about the distance from the center of the regular polygon to a vertex of that regular polygon. But distance cannot be negative, so we're not going to concern ourselves with that. But don't forget, when you get to algebra 2, you got to know that's plus or minus 5. You can take the square root of the value. Just for fun, what's the center of this circle? If you can raise your hand and tell me the center, the coordinates for it. Alex, you think you got it?
2, -3.
2 and -3. Okay, well that rate's -2, so why'd you put +2?
Well, because in the equation it's -2.
Okay, good.
It's minus.
You are subtracting whatever your x-coordinate is of your center. So the actual x-coordinate is a positive value. You're just subtracting that positive value. Here, for the y-coordinate, you're subtracting a -3. Whenever you subtract a negative value, it's like you're adding that positive. So good. We just want to make sure that we understand that formula. Cool. So from here, we've got the information we need. We know we have a octagon, a regular octagon, so that means r is equal to 8. We've got that the radius is 5. It didn't give us like units, like yards, inches, centimeters, whatever, so I'm just going to put a U for units. From there, it's just like all of those other problems up above there. The first thing that you need to do is find the central angle that's being created by 2 consecutive radii, and those will open up to one whole side length. How do we find the measure of that central angle created by 2 consecutive radii?
360 divided by n.
360 divided by n, in this case, since our shape is an octagon, n is equal to 8, so what is that?
45.
45 degrees. Alright, find that central angle first, then what's the second thing we do?
Plug in our known variables. So
Not yet.
Oh, draw our altitude or azimuth.
Yeah, we gotta introduce in our apothem. That apothem does 2 things. It's perpendicular to one of the side lengths of that regular polygon. It also bisects that side of a regular polygon, and it bisects that central angle that we just determined the measure of. Once we introduce that right triangle, then we can focus, once we introduce that apothem, then we can focus on this right triangle that will always be created by the same 3 segments. Apothem, radius, and 1/2 the side length. And so this green triangle, this green right triangle is right here. I just made it bigger so we can write in it. You will always be able to find the measurement of the angle created by the apothem and the radius, always. Because it's always going to be half of that central angle that is 360 divided by the number of sides. So in this case, for an octagon, a regular octagon, what is the measure of this angle created by the apothem and the radius?
22.5 degrees.
22.5 degrees. You will always be given one of these 3 values. We determined that we knew the radius was 5, so I'm going to erase r, and we know that this is 5 units. Okay, going back to the formula, we need to know what the apothem is. We need to solve for that. So we need to solve for the apothem length. Also, we understand that we need to find the perimeter at some point. The perimeter for a regular polygon is whatever one side length is times however many of those sides there are. So it's times n. So because we have to find the perimeter, we must find the length of one whole side length, which means with this right triangle, we've got to solve for this side. Can I use Pythagorean's theorem right now? No.
No.
Is this one of our special rights?
No.
No. So what's my only option?
Trigonometry.
Trigonometry. Okay. I'm first going to solve for my apothem. So I'm going to first solve for this guy right here, the apothem. I have to use trigonometry, so what trig function must I use to
Cosine.
solve for my apothem?
Cosine.
Cosine.
Changing number opposite.
In the set of parentheses is the angle measurement, in this case 22.5. Cosine compares the adjacent leg divided by the hypotenuse. So in this case, the adjacent leg is our apothem. It's just a coinkydink that apothem begins with an A and our adjacent leg A. So, it's a nice coincidence there. It's always going to happen. So we've got cosine of 22.5 is equal to the apothem length divided by the hypotenuse, which is 5 units. Whenever you're trying to solve for a side length, we put our trig function over 1, cross multiply, and solve for the variable. When we take the cross product, we got A is equal to 5 times cosine of 22.5. That is my exact answer. But when we type that into our calculator, we're going to get a rounded answer. Please make sure that your calculator is in degree mode right now. Please check that your calculator is in degree mode. If it is, then please plug in that. 5 times cosine of 22.5. Can someone give me the rounded answer? Raise your hand. Who's got it? I know Elsa's got it. Someone else. What's up, guys?
4.6.
4.6. Reagan, do you agree?
Yes.
Wonderful. So do I. 4.6. So we got our apothem length. Now we need to solve for our perimeter, which means we got to get our whole side length, which means we got to solve this side of the right triangle. Now, there's 2 ways of doing this. You can legitimately plug in 1/2 the side length in the ratio, just like we plugged in A. Or we can say, okay, this length, I'm going to call it X. And so I know that X is 1/2 of the side length, and then whenever you solve for X, you know that you need to double that in the end to get 1 whole side length. By show of hands, who has been doing this method where you say, I'm just going to call this X, and I know that in the end I need to double it to find the whole side length? By show of hands. Okay. How many of us have been plugging in, rather than coming up with a new variable, we are legitimately plugging in 1/2 times side length? Okay, cool. I'm going to do it both ways. I just want to make sure that everyone understands why I'm doing it 2 different ways. If we're going to use like a new term and say, okay, let X equal 1/2 of the side length, then this is what it's going to look like. What trig function am I going to use? Sine. So sine of 2.5 is equal to X is my opposite, and then divided by 5. But you have to remember, okay, X is 1/2 of my side length. That's what we let it equal. Then we're solving for our side lengths, put the trig function over 1, cross multiply, and solve for your variable. So this is going to be 5 sine of 2.5. My rounded answer is what?
1.9.
Say it louder. 1.9? Okay, but that's only half, and understand that this is a rounded answer. So when you double it, you're doubling a rounded answer. So, what is S?
3.8.
3.8 units. That's 1 whole side length. Then you can take that over here and say, okay, my side length is 3.8. I've got 8 sides. And you can easily find your perimeter. Alright, now instead of doing it that way, you could just straight up solve for not a new variable X, but you could plug in, if this is 1/2 of the side length, you could solve it this way. And so what you would get is cross multiply, and you get 1/2 side length is equal to 5 times the sine of 22.5. And then to get rid of this 1/2, you would multiply by 2 on both sides. 2 times 5 is 10 times the sine of 22.5. So you have the exact answer for 1 side length of this regular octagon. And then you would type in to get a side length 10 times 22.5.